When computers perform arithmetic, they perform arithmetic on binary values. So although we may want to add two integers together, 115 plus 37, and we want to give this task to a computer or a calculator to do for us, then these values are going to be first converted to binary form. So I've already taken care of that here, and we can see that 115 is the binary value 1110011, and 37 is the binary value 100101. Before we get to actually adding these, we have to think about a couple of properties, because the standard carry procedure doesn't work exactly the same way, though it is analogous. So we cannot say that 1 plus 1 is 2, because that exceeds the number of allowable numerals that we can use in binary. So here are a couple of fundamental rules of addition. If you add two zeros together, no doubt, that gives you 0 of however many 2 to the zeros or 2 to the firsts or 2 to the seconds you have. But suppose that we want to add 0 plus 1. Well, that's okay. That means we just have one 2 to the 0 or 2 to the first or 2 to the second, depending on which column we are in. So here we have 2 to the zeros, and how many of those do we have? If we add 1 plus 0, same story. And if we add 1 plus 1, this is where we have to be careful, because if we're adding ones together, well, 1 plus 1 is 2, but that means that we actually have to carry over to the next column. So we'll have 0 and what we call a carry of 1. Okay, so in other words, this is kind of like saying this equals 1, 0. So if you think about this as the number of 2 to the zeros that we have, if we have 1 2 to the 0 in our first binary value and 1 2 to the 0 in the second binary value, then that means we have 2 2 to the zeros. Or equivalently, that's like saying we have 1 2 to the first. And it doesn't matter which column we're in. We could be, say, here, and this is our 2 to the first, 2 to the second, 2 to the third, 2 to the fourth, 2 to the fifth column. And if we add 1 and 1 together, we basically are saying that we now have 2 2 to the fifths, or better yet, we have 1 copy of 2 to the sixth, and then 0 remaining copies of 2 to the fifth. So the arithmetic is actually quite straightforward as long as we follow these rules. So within each column, we're going to add, and then we're going to have a carry value, possibly. So 1 plus 1 is 0, carry a 1. We're basically saying that we have two 1s, which is 1 2 to the first. Now in this column, I'll have 1 plus 1 is 0, or 1 0, plus 0 is still 1 0. So I basically have 2 2 to the firsts, and if I have 2 2 to the first, that's like having 1 2 to the second. So we have 0 1. Now in this column again, we add 1 plus 0 is 1, plus 1 is 0, carry the 1. 1 plus 0 is 1. 1 plus 0 is 1. 1 plus 1 is, again, this is like saying now that I have an extra something that can go into the other column. So I have 0 of these and 1, in this case 2 to the 0, 1, 2, 3, 4, 5. I have 1 2 to the sixth. And now here I'll have 1 plus 1. Well, that means I have 2 2 to the sixth, or I have really 0 2 to the sixth and 1 2 to the seventh. So my final answer is 1 0 0 1 1 0 0 0. And the way we can check this is we can do our standard addition here. And the standard way we would carry here is anytime we exceed 10, we carry a 1 over. 1 plus 1 plus 3 is 5, and that should give us 152. Well, if this is 2 to the 7th, plus 2 to the 0 2 to the 6th, plus 0 2 to the 5th, plus 1 2 to the 4th, plus 1 2 to the 3rd. 2 to the 7th is, let's see, 32 times 2 is 64, 128. So this is equal to 128. 2 to the 4th is 16, and 2 to the 3rd is 8. So this gives me 24 plus 128, and that does indeed come out to 152. Now, one other situation that we might have arise is what happens if we have a carry of a 1, but suppose this was a 1 and a 1 and a 1. So if I had 1, 1, 1, and I added these together, if this represented 2 to the zeros, let's just say that that was in perhaps our first column and we were adding these together, then this basically says I have 3 ones. I have 3 ones. Well, in terms of how that would happen, well, that means I have 2 too many, right? So one of those ones can get carried over to the next column, and then I'll still have one left over here, or a single digit, and so 1 plus 1 plus 1, well, we know that that is equal to 3. Well, this value here represents how many 2 to the firsts we have, and this represents how many 2 to the zeros we have, and 2 plus 1 is indeed 3. And so that's the kind of the other case that we might encounter, that 1 plus 1 plus 1 will give you a 1 in the current column and a carry of 1. There is a more formal algorithm for doing this, but you can kind of see how it works out. Essentially, what we're saying is that we want to add 2 integers in binary notation. To add a and b, we'll call those values a and b. And those values a and b will, let's just say it has 3 digits, a2, a1, a0. So these aren't being multiplied, these are just 3 digits. It could be 111 or 100. And then I have some other number, perhaps it's b2, b1, b0, and I want to add these. To add a and b, first add the rightmost bits, which is what we did. So this gives a0 plus b0. These get added together. And this is going to be some s0, that's the rightmost bit in the binary expansion, and c0 is the carry. So for example, if I had 1 plus 1, which is 2, that's equal to 1 times 2 plus 0. And so this essentially means that I'm going to have a carry of 1, and this will go in the same column. Then add the next pair of bits and the carry, and kind of keep repeating this process until you make your way up through here. Not all of them are going to have carries. In some cases, like where perhaps this is a 1, 1 is equal to 0 times 2 plus 1. And so the 1 is what remains in the column, and there's a carry of 0, so we don't even have to worry about that. This is a more formal definition of it, and it would give us kind of a way to develop pseudocode or code in a specific language with which to do this.